So today, this next lesson is on the quotient of powers property. Again, we're working with shortcut methods for trying to simplify some of these powers that we have that have the same base. So today we're talking about quotients. If you don't remember what a quotient is, it's what you get when you divide two things. So that's what we are looking at today. So consider the fraction x to the 10th divided by x to the 5th. What would be another way to write this in expanded form? So write it out the long way. Well, hopefully you know we would have a fraction, and the top would have x's on it, so we'd have 10 x's on top. And we would have 5 x's on the bottom. Now, what I'm going to ask is, okay, what happens to when I have an x on the top of a fraction and the x on the bottom? So what happens when I get x over x, or x divided by x? And hopefully you remember that that means that they're going to cancel out. So this x and this x are going to cancel to get each other out. Same thing here, cancel, cancel, cancel. So what it looks like is that I'm left with some x's just on the top. So another way to write that would be to write x to the 5th power. Now many of us might be tempted using our shortcuts that we've learned previously to say, I think this is going to be x to the 10th and divided by x to the 5th. I think I'm going to do 10 divided by 5 to get my answer. Okay, 10 divided by 5 is not x to the 5th. So how do we get x to the 5th? What's our shortcut here? Hopefully you notice that our shortcut is that we subtracted our exponents this time. So we're going to subtract our exponents. So that would be our quotient of powers property. It says that if we have b to the m divided by b to the n, the same base, different exponents, I can just go ahead and subtract them. Of course, that's only when b is not 0. That's a good time to write that in your green notes too. So now we have a bunch of practice. I'm going to have you pause the video. I want you to try it on your own, okay? And then I want you to unpause the video and check out what your answers were. Let's go ahead and do that. So here are the answers that we came up with together in class for these problems. I'll let you go ahead and kind of skim through them and make sure that you got them all right. Now, on a problem like number 6, I don't mind if you write it as n to 0 or if you write it as 1. If it does say write it using powers, I would prefer n to the 0, but I would probably take either answer. And here are the answers for 7 through 12, so you should go ahead and grade those. Again, you can see all of my work that I did, so you know that I subtracted my exponents. I didn't do anything goofy, and just in case I did come up with the wrong answer, you can see that I still did it the right way. My subtracting was just bad. All right. So I know that some people have asked me already, Ms. Ring, when are we going to use these properties in real life? They're kind of boring to learn about. There's a lot of them. They're confusing. What's the point? So I wanted to give you a real life example where you might use this quotient of powers property in real life. So here's an example of the gross domestic product of a country is the total value of all the goods and services provided by that country. So when a GDP is divided by the population, it gives us the GDP per person. So GDP is kind of like anything that is made in the United States or any service that's provided in the United States contributes to our country's value or how much it's worth. And that's kind of how we measure countries against each other sometimes. And we can figure out how much it's worth by figuring out, okay, what's the GDP per person or per capita? Okay, that tells us kind of, okay, per person, how much money is everybody worth. So the first thing on this one that's really challenging for a lot of people is that we have to write 5.5 million in scientific notation. Okay, so I'm going to write it here, 5.5 million. So I know that I have 5 million people. So 5.5. Now I'm going to start adding zeros until my first 5 is in the thousand or in the millions position. So right now I have 5,000. And if I add 3 more zeros, now I have 5 million people. So if I write that in scientific notation, I get 5.5 times 10 to the 1, 2, 6. Okay? Then I have to do the same thing with Denmark's GDP. Okay, they told me that it was $243.4 billion. So I know that 243 is in the billions place. So I'm going to start adding zeros. Now I have 243,000. Now I have 243 million. Now I have 243 billion. So if I want to write that in scientific notation, that would be 2.434 times 10 to the 11. Now, big whoop, we can write it in scientific notation. What we want to know is what is the GDP per capita or per person? So remember, GDP was given to us in dollars. Okay, so we want to know the GDP in dollars per person. So I'm going to take these two numbers and I'm going to divide them. So I have 2.434 times 10 to the 11th divided by 5.5 times 10 to the 6th. Now, I could go ahead and put that into my calculator. Chances are I'm going to mess it up. I'm not going to use parentheses. So let's make our life simple. We know a shortcut here. We know that we can take 10 to the 11th and 10 to the 6th, and we could subtract those two exponents to get 10 to the 5th. Which then leaves us with 2.434 divided by 5.5. That is much easier to put in my calculator, and I am confident that if I do put it in my calculator, I'm not going to make any silly mistakes. So when I do that, 2.434 divided by 5.5, I get 0.4425, and I'm going to round it to 4 decimal places because it's kind of a long one. So 0.4425 times 10 to the 5th power. If I wanted to write that number in expanded form, write it out the long way with all the zeros, I'm going to move that decimal place 5 times. 1, 2, 3, 4, 5. So it looks like I have to add 1 0. And remember, it's always important in a word problem, always important that you include a label. So remember, that was dollars per person. So in Denmark in 2006, GDP per capita was about $44,250 per person. If you'd like, you can try another problem like this. It might be a little bit easier because the numbers are already in expanded form, so writing them in scientific notation might be a little bit easier. But we do need to also talk about dividing powers with different bases. So for any of the shortcuts that we've learned, any of them, we know that they only work if the bases are the same number or the same variable, okay? That's really important. So we have to be extra careful when we start doing these quotient to powers property that we don't simplify things that don't have common bases or the same base. So something like here, a to the 5th divided by b to the 2nd. That's 2 different bases. We can't combine those. We can't simplify it any more than it is right now. So if we would like to divide 2 algebraic expressions that involve different bases, first start by grouping the powers of the same base together. So I'm going to group my a's together, my n's together, and then my 30 and my 5, because I can figure out in my calculator what 30 divided by 5 is. So I get 30 over 5, a to the third over a to the second, n to the sixth over n. I haven't changed anything. I just kind of broken it up because it's kind of like when you eat too much ice cream and you get a brain freeze. If you try and do too much of this math and you look at it as a big jumbled mess, you're going to get a brain freeze, okay? So break it up, make it 3 easy problems to work with now. So now we can simplify 3 minus 2 and 6 minus 1. And what we end up with is 6a to the 1, n to the fifth, okay? So we simplify each individual fraction, then it's much easier to complete that way. So what we're going to have you do is practice dividing powers with different bases. And once again, you can pause it, complete it, and then check your work. So here were the answers that I had come up with for 1 through 6. You can check yours, see if you got them. If you did, that's great. If you didn't, you can take a look at what maybe you did wrong. Okay. Once again, a lot of people really try and go really fast through these, and they make some very simple, silly mistakes. Okay, so break it up. Make sure that you break it up. So make sure that you're writing something like 40 divided by 8, b to the 10 over b, c to the 3 over c to the 2. Okay, really break it up. Make it easier for your brain to handle. All right, that is it for this lesson. The last thing to do is to complete the OTL number 3. So hopefully you have what you need to do that one.